Now that we've looked at proofs where we prove that two triangles are congruent, we're going to take it a step farther and we're going to prove that segments or angles in triangles are congruent. And we're going to do that using CPCTC. So remember, it means corresponding parts of congruent triangles are congruent. It's a lot of words, a tongue twister, and a lot of writing, so we just call it CPCTC. And all that says is that if I know two triangles are congruent, like if I'm told that, order matters and all of my letters correspond. So just by looking at this congruence statement, I know that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. And I know my sides are congruent as well, so I know AB is congruent to DE, and BC is congruent to EF, and AC is congruent to DF. All of that because my letters line up and they're corresponding. We're going to use this theorem to take our proofs that we've already been doing one step farther. So for example, here's my picture, my given, but this time instead of proving that the triangles are congruent, I'm going to prove that these specific sides are congruent. To do that, I still need to prove that my triangles are congruent, and we're going to do that the same way we've been doing. So I'm going to have my two-column chart. I'm going to start by putting my givens at the top, so I know that QK is congruent to QA. That's a given. And that QB bisects angle KQA. Also a given. So if I come back to my picture and I label those, QK congruent to QA, put a dash on both of those. For something to bisect, it means it's cutting it in half. So it's taking this angle KQA and dividing it into two congruent halves. So that means that KQB has to be congruent to KQA, or to BQA. Alright, so I took this big angle at Q and I divided it into two. And I want to prove that these triangles are congruent. So there's one other part that I can label, and that's the reflexive property right down the middle. So now I'm going to add all of this to my proof. KQ and QA is already in there because of the given. Then I was able to label these two angles here to be congruent because of what it means to be a bisector, or for something to be bisected. So I need to add that in here and say that angle KQB is congruent to angle BQA because of the definition of a bisector. And then the last thing I labeled was this reflexive property down the middle. So we can say QB is congruent to QB because of the reflexive property. Right? Once I labeled all of that, I can see that my two triangles are congruent by side, angle, side. So I'm going to have to write that out, and remember, order matters. Before, when I was trying to prove that triangles were congruent, my proof statement is all I had to write. Well, now I've got to think about the letters and how they match up. So if I call the first one KQB, so I started at K and I went on the 1 dash side to the 2 dash side. So if I do that for my second triangle, it would be AQB. And these are congruent by side, angle, side. The side that I'm trying to prove congruent is that KB is congruent to AB. Well, because I know my triangles are the same, that means all their corresponding sides have to be the same, and KB and AB are the same corresponding side. So my last step is just going to say that they are congruent by CPCTC. This top part is the same exact thing we've done before. The only difference is now we're going to take it one step farther and use CPCTC.